Hello and welcome to Electronics with Emrys. This is a beginner-level hobbyist kit for building your own 9-volt battery tester, and this video is intended as instructions on how to put the kit together. If you're more interested in how to build your own version of this, I have other videos that go over exactly how I made my component selections, my design decisions, and building everything from the schematic to the PCB. So you are absolutely welcome to go to those videos and work your way through the entire process yourself. I decided to sell these as kits because it will definitely save you time and effort, especially if you're a beginner, if you want to just get the kit and then work on your soldering and understanding the circuit first before you worry about making things like design decisions and your own PCB. If you're interested in getting one of these kits, shoot me an email at electronicswithemrys@gmail.com and I'll discuss the details with you over email. The rest of this video is intended for someone who already has the kit and wants to put it together. One last thing before we get started, I am not going to be teaching you how to solder in this video, and I'm not going to tell you what equipment you need to be using. So I am going to link videos that do discuss that in my description. So I would highly recommend you go watch those if you're not sure what type of soldering iron you want to have, what type of solder to use, and other tools that are going to be used in this project. Before we start building anything, let's make sure that you have all of the components that you're supposed to have for building this. Inside the kit, you should have the PCB, a sheet of resistors, and an ESD safe bag. The sheet of resistors just makes it a whole lot easier to pick out which one goes into which spot on the board. If for some reason they came out of there, it's very easy to just measure it with a multimeter or even look at the color code to figure out which resistor goes where. Inside of the ESD safe bag, you'll find all of the other components. You should have 4 red LEDs, 3 yellow LEDs, 2 green LEDs, 3 of the smaller capacitors, which are 0.1 microfarad, and 2 of the larger capacitors that are 2.2 microfarads. You'll also have 1 diode that looks an awful lot like a resistor, and you'll have 4 ICs. 2 of them are the dual inline packages, which are the LM339 comparators. 1 of them is just a transistor, which is labeled as Q2, and 1 of them is the LDO regulator, which is labeled as U3. I want to say thank you very much to my son who helped me out with this video. When he heard that I was making a beginner electronics kit, he volunteered to have his first time soldering done on camera so we could show just how easy it is. A quick disclaimer here, soldering can be dangerous, so you definitely need an adult supervision to do it. Don't go playing around with dangerous things just because you saw it on YouTube and you think it looks easy. Please, please, if you are under 18 and you're wanting to get into electronics, discuss it with your parents first, and find some good training materials on safety before attempting anything shown in this video. That being said, I think soldering is an important skill for anyone to have, and this is a great project to get started with. And then we're going to pull one off the end, so see how it's stuck to that tape kind of? Yep, keep it out there. Okay, cool. So then, that's good. We only need 1 of these. So we're going to put the rest back. I'll take those. Oops. Okay. So now that is R1. So that's a 1.74 kilo ohm resistor. So I marked it there where we can easily see.
Okay.
And that guy, 1.74K, is R1. So can you find R1 on the board there?
I found R17, but
yep, R17. They're kind of in order, so if you look around, you'll see how the resistors are numbered. There you go. So now you want to take your resistor, and you want to bend it so that you have kind of a staple shape.
Like this?
Yep, like that. You want to show the camera? Kind of like that. Okay, so then we're going to stick that through the R1 holes, and we're going to have to pick up the board and do that. So hold the board over here and do that. Should slide right through. Super easy, right? Push it all the way down to the board. Okay, you got it on there?
Yeah.
Bend it out away. Bend them away a little bit. So you want it to stay in there, right? You don't want it to fall out. Oh, so there you go. So we got it. Now it's on there. that's all the way down to the board the way we want it, so we can show it real quick to the camera. So we'll just get it to where it'll focus there. You can see that resistor is in the R1 spot through both holes, and then on the back.
Should I cut the lights? Yeah.
Yep, we bent the legs. No, we have to solder it down first.
Oh, okay.
So what we're going to do is we're actually going to solder it from the back, right?
Okay.
So then you want to clamp it on there. So yeah, so what you want to do, so let's do it cold first so you can get the feel for it. So you're going to take the soldering iron, grab the yellow part. Yep, there you go. It's kind of like a pencil, just don't grab the end. And then you want to take that and get the flat part against the bottom of the board. Can you see how the tip has like a flat part and a sharp side? Look at the end. You see how it's got different shapes on it?
Mm-hmm.
So you see how there's a flat side?
Oh, you want the flat
You want the flat side to touch the board. And you don't need this guy yet. So you can hold it, but you don't need it yet. You're going to take this guy and you're going to touch all the way to, you want to touch the board itself and this guy, and you're going to tilt it up a little bit so you kind of stab it down in the corner there. There you go, perfect. And that'll heat up both pieces at the same time, because you always want to heat up what you're connecting and the board.
And then I can slide
And then
this.
you're going to put solder into there. And that's it. And then you just put a little bit of solder in there and then take it away and see if it looks good. If it's good, then we're done and we do the next one.
And then I do that, and then like that.
Yep, that's all it's going to be.
Okay.
It's just holding a 700-degree soldering iron when you're doing it.
That doesn't sound fun. Why did I do this?
Yeah, you'll be fine.
Okay, so it's heating up right now, right?
Yep, so you can see that it shows the temperature
It's
here.
already going up that much?
Yep, that's 200 Celsius. And it'll be 300 in a few seconds. And this thing, I usually give it a good 5 or 10 seconds once it's heated up, because this number is not exactly what that is.
Exactly. If I put the solder onto the tip right now, it would.
So why don't we
melt.
test it real quick? You can take your soldering iron out, and then be careful because it's hot. And then careful that, and then take it out and hold it here somewhere, and then touch the solder to it just a little bit and see if it melts. Oh, yep, there's a bunch of smoke coming off. So there you go. So now you should be able to solder this thing.
So do I do it quickly, or do I just take my time?
You want to hold the soldering iron on there for 2 or 3 seconds to warm it up first, and then put the solder on there. So you just kind of hold it there for a while. It won't hurt it any.
Okay, so
Just touch it on there. And 2, 3, there you go. And then see if you can add some solder in there. It can be a little challenging to get in that corner. Okay, then take it away. And so now that joint is soldered.
getting it close to here.
Yep, that gets all the fumes taken away, right? Then you want to do the other side.
Can I roll this
Yep,
out?
you want to roll that out. And also, if you kind of grab it like this and like pull, you can get it to kind of bend the way you want. So you can get it to bend away or towards. And I like to bend it towards because then you can do this. Okay.
Okay, so we have to have this flat part there.
Yeah.
1, 2, 3. And pull back. Yeah.
Looks like it's pretty good.
Alright.
Let's take a look at that real quick. You want to put the soldering iron in the holder there. So now we're done with soldering iron, unless you want to do more than one today.
I'm good.
Okay, so I'm just going to show the camera here real quick what this looks like. So these are the solder joints we got. It looks like there's a little bit of solder that came off to the side of one, but they look really good.
Cassie,
They look
which
really
one
good.
I did that with?
So yeah, it looks like there's a little bit off to the side there. That might just be resin though. Once we clean it up, we'll see. So we got 2 more steps to do here. So, but that resistor is pretty much on there. So we should be good. So but now we're gonna snip those legs off and snip them just like a little bit above the solder. And no, not that far. Just right above it. There you go. You got it. You don't want it to be too long and stabbing you, right?
Right there, right?
Yep. It's fine.
Nice.
Okay, cool. So we got that. And then the last thing we can do is clean this. So take this stuff and squeeze just a little bit onto those 2 spots we just did.
Oh, jeez, that's
And then you can use this to scrub around it and try to clean off the gunk around.
Am I able to put my hand here?
Yeah. It's not hot anymore. This guy's hot.
I would have assumed that, but just kind of know.
Yeah, you're good.
I have not had very much cleaning experience.
Looks pretty good though. You see how that little blob is gone. So it's not actually solder. That was just resin
Jeez.
or rosin. It's the flux. the stuff that helps the solder stick. Cool. So then last step here is just to check that we actually got a good connection.
Okay, and we put it
We
on.
can take our multimeter and then we're going to look for where the wires go to that resistor. So can you flip the board back over on the other side?
Yep.
So do you see where those wires go to? So it's a little confusing here, but I can show you. This end of the resistor goes through this little T right here. See the T?
Yeah.
And it goes down here to this pin right here.
That's what I was thinking.
Yep, that's where one end goes. Then the other end actually goes over here to that.
What?
So that end, if you can see there's little legs sticking out the sides there.
Oh yeah, I can see that.
Those connect all this green stuff. Everything here is all connected together. So, and that one also has those little legs. So we can just check from here to there and from here to there. So you want to do that?
Sure.
So here you go. You can take these and you can check the resistor.
So from here.
Oh, here. Hold on.
Here?
Let's slide this guy over here where we can see it on camera.
Let's move this a little bit.
Perfect.
Alright, so you want to do it right here and right here.
So that should say 0. Perfect.
Alright.
And then the other end of the resistor.
Here and here.
That's 1.736, so 1.74 kiloohms. Perfect. That's what it's supposed to be. So then check from this hole right here over to that one over there.
This one and this one.
Yep. So that should be 1.74K if we did it right. Yep, you did it. Good job.
Yay!
So that resistor is on the board. You don't usually have to double check like this, but I just wanted you to get a feel for how you can check it.
Oh, that's beginner approved.
Cool.
I like that.
The alligator clips I use to hold my boards can actually damage the PCB, and in this case actually shorted out my VCC and ground at one point. Fortunately, it didn't damage anything, but you can learn from my mistakes and either use clips that are not sharp to hold the board, or add something between the clips and the board like some tape or paper just to prevent damage. Having a little solder on the tip helps with heat transfer because the liquid solder will mold to the shape of the component. You still need some fresh solder though, mostly for the flux. Especially with through-hole components, you can use thicker solder than what I am, but I really like the control a thinner solder provides. When you first start soldering, it's easy to use way too much. You'll know if you do that because you'll end up with big bubbles of solder instead of little Hershey's Kisses on the board. Cut the legs short to avoid having sharp points coming out the bottom of the board. You should be careful not to cut the solder joint though, as that can weaken or even break the joint. Some solder came through the board, which is fine. The longer you heat a joint, the more likely it is that that's going to happen. Values are written directly on the board just as an extra quick reference. The LED resistor values are not correct on this first version of the PCB. I'll definitely discuss that whenever anyone orders a board, so you'll know which version you're going to be getting. For the resistors, you really don't need any ESD protection, but when you get to the ICs and diodes, you really should have some form of ESD protection. An ESD strap with a good ground mat is the best solution, but you can also just touch a grounded piece of metal to discharge yourself before you start working on sensitive components. I used the latter approach for many years without any issues, but now I use an ESD strap just because I have one. For PDIP or plastic dual inline packages like these, sometimes the legs are bent out a little bit and won't go into the footprint on the first try. Here I try to just nudge the legs into the footprint a bit with my fingernail, and after reseating the part, it worked out fine. I like to bend over the corner pins just to make sure the part doesn't fall out while I'm soldering. Another method I found useful is to lay the part flat on the bench and tilt it over just a little bit to bend all the legs at the same time. You have to be careful with that one not to bend them too much. Just like with the resistors, we want to make contact to both the pin and the pad, then apply solder to the opposite side of the pad to fill it with solder. If you find you're spending a long time on each pin, it's a good idea to switch to the opposite side of the part for a pin or two to avoid overheating the part. Most capacitors, like these little ceramic ones, do not have a polarity, meaning you can put them in the circuit either way, just like a resistor. The bigger ones we're using are electrolytic and do have polarity. make sure to put the negative pin through the hole marked with the solid white on the PCB. If you don't want to have the animation that takes a second whenever you test the battery, you can leave off C5 entirely. The tester will still work perfectly, it'll just light up the LEDs all at once. You could also change the C5 value with either a smaller capacitor to make it faster, or a larger one to make it slower. I'd say values between 1 microfarad and 10 microfarads would be reasonable to try out. Here I show how to do a quick check to make sure the capacitor pads aren't shorted together, because they are pretty close. As long as the resistance you measure is in the kiloohms or larger, you shouldn't have any problems. If you do find that there's a short here, you probably used a little bit too much solder, so you may have to use some solder wick to remove it, or you can use some flux to touch up the solder joint and get the two pads to separate. It can be a little challenging to get these three-legged packages to stand up the way you want them to. One trick is to solder in just one leg and then bend them the way you want, then finish the other two legs. For the regulator, the footprint has the legs spaced out a little more. We can just bend the middle leg out a little bit to get it to line up. Sorry about taking that off camera there. Be careful not to bend it around too much, or you might end up snapping off the leg, and that can be pretty hard to fix. On the diode, the cathode, or the negative terminal, is indicated by the line in the rectangle. On the LEDs like D9, the square hole and tiny mark indicate the cathode, or the negative pin. You can tell easily from the wiring of this LED in particular because it's right next to the battery, and it's intended to light up when the battery is reversed. So the negative leg of the LED goes to the positive battery terminal. The reverse LED only turns on if the battery is reversed. I'll mention it again later, but for most through-hole LEDs, the anode is the longer pin and the cathode is the shorter pin. For this board, just make sure the shorter pin is going into the square pad. The black line on the diode needs to be on the same end as the stripe on the footprint. You can always check polarity with a multimeter if you aren't 100% sure that you got it right. The LED has the long leg being the anode, or the positive terminal. We can also use the multimeter to double check that we have the right polarity. Again, with the LED, I solder just one leg, then position it before soldering the other leg. This is just for aesthetics, but on a build like this, I think it matters. For the LEDs, make sure the anode, which is the shorter leg, is going into the square hole. There's also a little bit of a mark on the silk screen, but it's kind of hard to see. I sometimes use this technique where I hold a component and the board with one hand, being careful not to touch any metal that'll get hot, then use the soldering iron with some solder already on it to stick one leg to the board. This helps me get components right up against the board. The solder joint won't be good, but it should be enough to get you positioned for the other leg, and then you can come back and just touch up the first one with a little bit of flux or fresh solder. So then we can turn around. You can see these are all over the place. They're all wiggly, right? So I'm going to try to straighten them out to the way I want them. Sometimes those solder joints might break like what this one just did. It's not a big deal. I'm just going to hold them down again and tap them again. Get that solder to remelt on there. That's why these aren't good solder joints. They're just temporary solder joints. So, alrighty. So this is much, much better. And that last one's giving me a hard time. I'm going to remelt him real quick. Right like that. Yep, try that again. And we can see, there we go. That looks pretty good to me. You can see they're all pretty aligned. Look down the side, they're all pretty lined up. Not bad. These stick out of the board just a little bit, the way they're designed. So, now we just have to put them in place permanently. That'll be the end of this project, except for cleaning the board. And you note I'm doing one leg of each first. These are the legs that I did not tack down. And that way, all of my LEDs should stay in the same orientation. Should have a pretty easy time getting them to stay put while we solder the other leg back. The other leg's going to need less solder, but still it needs to be soldered on well. We need to get some flux on it, which the solder I'm using, and most solder has a flux core. So, alright, so then I'm just going to turn it over, double check that all these LEDs still look good. Yep, everybody's still where they're supposed to be. So this is perfect. And we can go ahead and finalize this board. That's the final board with everything on there. Looks pretty good. I'm going to clean the flux off the back of this before I go attempting to power this on, because flux can cause some issues if you don't have it if you don't have it really cleaned off there, it can short things out and cause other issues. So I'm just going to come along and lightly brush this with a toothbrush to get the flux broken up in there. Anything that might have been stuck to the board. A little bit of solder got stuck to the board there. Should be set. Then we're just going to come along with a cloth and wipe out the majority of this. Should be pretty good at this point. Alright, so let's see what happens when we power her up. If we hook up a battery with 6 volts on him, one LED turns on. Okay. That's 6.3 volts technically. I'll turn that up to 7 volts. We'll see. 3 of the LEDs come on. Let's set this up to 8 volts. 4 LEDs are on. 8.7 volts. Oh, we got most of them on. And then we're going to do a little over 9 volts. Oh, that's in the green. And then we're going to go to and put it at 9.8-ish volts, and we should see all of it on. So that is a totally green battery. And now if we reverse it, we should see no LEDs, just the reverse one letting us know we did it backwards. This last little bit is optional. You can add some solder onto the battery contact points to make it a little bit easier to contact the battery onto the board. This also makes it easy to touch up the board later on. If your contacts start to get worn, you just add a little bit more solder.